G'day guys, we're going to start looking at three-dimensional trigonometry. 3D Trig doesn't use any new trigonometry. There's no trigonometry in 3D Trig that goes beyond, well, in exercise 5C at least, there's no trigonometry in it that goes beyond what you learn in Year 9 trigonometry. Okay. There is no algebra beyond what you learnt maybe in Year 10. The reason why we wait for advanced maths in Year 11 before we do 3D Trig is because, well, for three reasons. One, because sometimes the triangles that we're talking about are not immediately apparent, and you've really got to kind of think outside the box a little bit. No pun intended there. So picturing the triangles we're talking about can be a little bit tricky, and because we need to pull in ideas from Trig and from sort of different levels of algebra that we've done and combine all of those things into the one problem. So no new ideas, just bringing old ideas in to handle more complex problems. Okay, nothing is beyond you guys, I'm sure. Okay, don't panic. So I'm going to look at questions 7 and 8. So we're going to start by looking at question 7 from exercise 5C of the Year 11, of the Cambridge Year 11 Advanced Mathematics textbook. It begins by telling us about a tower that's 30 metres tall, that stands at a point B. The top of the tower is a point T. The elevation of T from P, which is due south of the tower, is 15 degrees. Okay, so because the tower is on level ground with, P is on level ground with the base of the tower and the tower is vertical, we've got a right angle here between PBT. Q is due east of the tower, so that's a right angle there as well. Okay, it's got an angle of elevation to the top of the tower of 18 degrees. Now, between south and east, of course, there's another right angle here. Okay, might be a little bit hard to picture, but we're looking at a 3D shape. So if I was to, I'm looking around the room for a convenient box and I can't find one. So I'm just going to have to get you guys to trust my fantastic drawing skills for now, okay? So imagine we're looking down into the corner of a box here. So this edge and this edge are flat on the bottom of our box, they're at 90 degrees, okay? This edge and this edge form the back of our box, they're at 90 degrees, and this edge form the side of our box, that's why they're at 90 degrees. So that's where those 90-degree angles come from. The question comes in two parts, but ultimately they want us to find the length of x, okay, the distance between P and Q. And this is all we're told, right? We're only told the height of the tower, angle of elevation, and the fact that these are one's due south and one's due east. Okay. The question's got to kind of hold our hand a little bit. It says, show that BP is 30 tan 75. BP. So they want us to find this distance here first. So I'm going to call this length over here, I'll call it Y. So they're talking about, well, let's us pull it out. They haven't actually told us. So what we're going to do is we're going to pull out this triangle here from the side and lay it flat on our board. So we're going to pull out the triangle TBP. Okay. So I've picked it up from there. I've come along and I've laid it flat on the board over here. There's my 15 degrees. There's the side that I've labelled Y. There's my right angle, and that's 30 metres up there. Okay. Now they're asking me to show that that this side here has got something to do with tan of 75 degrees. Well, where's the 75 coming from? Well, if this is 15 degrees up here, then obviously this is 75 degrees up here. Okay, so what do we know? We know that tan 75 is opposite over adjacent. So the tan of 75 degrees is y over 30. So y is 30 tan 75. Well, what's y? Well, y is BP. So BP is 30 tan 75. Okay, I'm going to replace my diagram with that. So call this distance over here 30 tan 75 degrees. Okay. Now they ask me in one foul swoop. Oh no, they don't. Sorry, I lie. They're asking me to get a similar expression for BQ. BQ. Well, let me take that triangle. I don't have to take it out of there. We can clearly see how it's a right angle triangle. There's my length BQ. Let me do what they did before. So they worked on this top angle over here. I'm going to do the same thing. I'm going to get that top angle up here. Okay. So that angle up there is going to be 90 minus 18 to make up my 180. I've got a 90 degree angle there, 18 degrees there. This angle here is going to be 180 minus 90 minus 18 is going to be 72. Yep, okay. So here's 72 degrees up here. I should put in that's 75 degrees up there so we know where things came from. 72 degrees there. So we know that tan of 72 equals BQ over 30, because tan is opposite over adjacent. So BQ is 30 tan 72. So let me write that in. 30 tan 72 degrees. And now they ask me to find x. Okay, piece of cake, because x is, look at this, I've got a right angle triangle and I know the two short sides. Well, if I've got a right angle triangle, I know the two short sides. It's begging me to use Pythagoras' theorem. Okay, so let's do that. Let me clear some of this stuff out of the way. So Pythagoras tells me that x is going to be the square root of 30 tan 72 squared plus 30 tan 75 squared. Now be very careful with your square roots and your brackets. So the square root of, in brackets, 30 times the tan of 72 squared plus, in brackets, 30 times the tan of 75 squared, also in brackets. Oopsie days. Okay, so we get 145.12 metres to 2 decimal places. Okay, so the two landmarks P and Q are 145 metres apart. Okay, sorry, the question actually asked for the nearest metre, so we give that as 145 metres to the nearest metre. And that's question 7 done. Okay, so I mean they held our hand a little bit. It's not like they sort of put the diagram up there and said find x, but what they showed us, the steps they led us through, kind of give us a little bit of a hint as to how we do the harder versions of these problems that are going to come up later on in the exercise, right? So please keep this in mind. Let's have a look at question 8. Okay. So question 8, I might actually clean the board and come back with question 8 up on the board so we're ready to go. So through the miracle of time and television and YouTube, we'll be right back with question 8. Okay, bam, just like that, as easy as that, we're back with question 8 up on the board. So question 8 gives us a tree, BT, and we don't know how high the tree is, okay? So it's H metres high. Ultimately, that's going to be one of the things we're going to find out, right? So we want to know how tall this tree is. Now it says that the tree is north of P. Well, that's another way of saying that P is south of the tree, right? So here's P down here. It's exactly like it was with question 7. Q is, and the tree is west of Q. In other words, Q is east of the tree. Again, exactly like it was with question 7. So we've got a little network of right angles in here. We're told this one that P and Q are 50 metres apart, okay? And that the angle between, the bearing rather, of Q from P is 36 degrees. So if you're at P and you're facing north, you're looking at the base of the tree, you're looking at the tree, okay? You need to turn through an angle of 36 degrees to be facing Q, right? So, and then the angle of elevation of the top of the tree from Q is 28 degrees. So with just those facts, they want us to find out a few different things about this scenario. So they kind of, again, they hold our hand. They ask us to begin by showing that BQ is 50 times sine 36. Well, here's BQ. Here's my right angle triangle with BQ and 36 degrees. Okay. So let's have a look. If I was to take this triangle out, so there's P that goes up to B, that goes across to Q. There's my right angle. There is my 36 degrees. There's my 50. Now BQ is that length up there. We'll have a look at this. I've got my opposite and my hypotenuse. Well, which ratio uses opposite and hypotenuse? The sine ratio. So the sine of theta is opposite over hypotenuse. Sine of 36 equals BQ over 50. So BQ does in fact equal 50 times sine 36. Just as we were asked to demonstrate. Okay. So here we go, 50 sine 36 degrees. Okay. Then they jump straight in. They're not shy at all. They go, hence find the height h of the tree, correct to the nearest metre. Well, this is again pretty straightforward. Have a look at this. I've got a right angle triangle here. I know my adjacent side. I'd like to find my opposite side, and I know this angle. So this is going to be a very straightforward tan ratio question. The tan of 28 degrees is my opposite side, h, over my adjacent side, 50 sine 36. So h is going to equal 50 sine 36 times tan 28. Now I want that to the nearest metre. So we've got 50 times the sine of 36 degrees times the tan of 28 degrees is 15.6. The nearest metre is 16 metres. That's a tall tree, okay? So the height of our tree is 16 metres. Question C says to find the angle of elevation of T from P. So there's T, here's P. They're asking us to find this angle over here. Okay, well, what do I know? I know the height here, so I know that's 16 metres. But But that's all I know in this triangle here. There's nothing else that I know in that triangle. I need to find another side. So I'm going to find this side over here. I'm going to find BP. It's going to be the easiest one for me to find because I know that that's 36 degrees. I know that's 50 metres. So look over here. I want to find BP. BP would be this length in here. Okay. So to find BP, I've got my adjacent and my hypotenuse. I'm going to use the cosine ratio. Okay, so just give myself a little bit of working space. Okay, so the cos of 36 degrees is the adjacent, BP, over the hypotenuse 50, so BP is equal to 50 times cos 36. Okay, well I know the height of my tree, I know BP, I need to find that angle. It's a very simple tan problem. Let me take this triangle out and lay it down so we can see it really clearly. There's BT, there's P, okay, my H is equal to 16 metres, remember. There's the angle that I want to find. This side along here is 50 times the cos of 36 degrees. Okay. Well, tan theta is opposite over adjacent, so tan of theta here is going to equal 16 over 50 cos 36. Well guys, it turns out that YouTube isn't that magical because my SIM card got full literally right at that point. Anyway, all that was left to do in that problem was to just punch those numbers into our calculator, and we got, as we can see on the board behind me there, 21 point something degrees. To the nearest degree was 21 degrees, and that's all that was left to do. Look, there was a little bit of algebra. There was a little bit of thinking about triangles in different ways. So we had to sort of take triangles from here and sort of twist them around and lay them sort of in different orientations, so we could get our head around how we could apply some of those 90-degree trig ratio ideas that we've seen. But that's all there was, guys. A little bit of algebra. That's it. Okay. A bit of Pythagoras' theorem. Start at question 1. Plug away. Don't expect to be able to do every single question without asking any questions yourself. That's not the way this thing works, guys. Okay, so the idea is that you do some of the easy ones. They will expose any major sort of gaps in your understanding. And then you work through, and as the questions get increasingly more and more complicated, then your understanding goes up. When you hit a wall, that's when you're meant to put your hand up and ask questions. It doesn't mean there's anything wrong with you. It means that you're learning. You're being a student. That's how it works. Okay. Good luck, guys. Please work hard. Please ask me all the questions in the world that you need to. Okay. Don't leave anything that you don't understand that you haven't asked a question about. Okay. Ask me. I'm more than happy to help. Ask anybody who is capable of rendering the help to you, but get the help that you need. Thanks very much, guys.